Hello and welcome to this presentation on Snort 3 and me, a Snort 3 introduction and overview. My name is Alex Tadashev. I'm a Cisco technical marketing engineer. I came from SourceFire, where I used to teach the classes on Snort 3 and on the 3D system. So I've worked with Snort quite a bit, and I'm going to help you understand some of the ins and outs and the main features of Snort 3, which is just released this year. So the agenda today, we're going to look at some overview and goals of Snort 3 development. When Snort 3 was written, what goals were they trying to get to and what were they trying to accomplish? Then we'll look at Snort 2. So Snort 2 is a good place to start because it's a product or an application that a lot of us are familiar with already. I know I'm pretty familiar with how Snort 2 works. So I think we start there. We can see what Snort 2 is like, some of the challenges maybe, and then move into Snort 3. To look at architecture then of Snort 3, how it's created under the hood, kind of some of the underlying pieces there. And then I'm going to take that and just look at some selected highlights. So highlights of Snort 3, how you might use it, some of the benefits of moving to it, and kind of why you should. All right, so let's start off. What is an IPS in Snort 3? Well, IPS is an intrusion prevention system. Basically, it's a network security prevention technology that sits on your network and looks for stuff inside packets. It's there to detect and prevent exploits. Now, Snort 3 is just an updated version of Snort 2, which is kind of the probably the most famous IPS historically in the last couple of decades. So Snort 2 with a new architecture improves the performance, detection, scalability, usability, much more modular. This also provides the foundation for the Cisco secure firewall, which was formerly called Firepower. So that's kind of the core threat detection technology within that secure firewall. Goals and features. Okay, so when we decided to, Snort 2 needed an upgrade, which we had decided a few years ago, what we were looking for? Well, first looking for efficacy. So we want a modern architecture for viably handling Snort 2 evasion. So there are a number of evasions that attackers are always trying to use to get by the IPS, right? So the idea is to get your attack through the IPS, kind of disguising it so the IPS misses that. That's called an evasion. And there have been plenty of those over the years. We've dealt with most of those quite well, Snort 2. But we want to be able to have a better way to do that, to handle those evasions, much of which are packet-based. Also, HTTP2 is important. HTTP2 is a new protocol that is not supported by Snort 2, so we want to make sure that's in this Snort 3 version. More capabilities for the Internet of Things, or IoT. Multi-session signatures, right? So instead of being packet-based, be session-based and be able to look for something within a session, not just within a couple packets. Intelligent traffic normalization. Okay, so normalization is one of the real key features of Snort 2, and that is taking traffic and turning it into something that's understandable and standardized for the rules engine. And so we want to be able to do that in a better way and to identify those obfuscated threats. And we also wanted to improve the rules language. So the Snort rules language is really the default or de facto standard for lots of in the security, network inspection arena, but we wanted to improve that. There's some inconsistencies there, some inconsistencies in the way the rules options are laid out. No comments, for instance, so need some improvements there. So that's another goal. Performance, we wanted a significant performance improvement over Snort 2. Right? So we know that there's some things Snort 2 is not doing as efficiently as it could, so let's try to improve on that. One of those is acceleration. So we want to be able to accelerate things like the searches. So regex, or regular expression searches, have historically been one of the worst performing keywords really you can have in Snort is the PCRE keyword. So we've been able to write around that pretty well. We can architect rules to make up for that deficiency or that slowness in that particular keyword. But we want to make sure, we want to accelerate that. So that's where we're going to have some acceleration technologies in Snort 3 and a more efficient memory utilization. As far as modularity, we want a faster time to market to be able to support new use cases. So to do that, we've made it very modular. So there's something like 200 plugins in Snort 3 right now, and pretty much everything is implemented in Snort 3 as a plugin. So that's part of that modular design. So it also helps Talos, the Cisco security group, address those zero-day issues with new rule options or inspectors quickly and efficiently. Also, it makes it more deployable. It's a cloud service, again, because it's probably going to be it's a lower memory footprint, which helps in those cloud and IoT cases. And improved maintainability and telemetry is important too. So more telemetry, more monitoring has been built into Snort 3 than was already present in Snort 2. Okay, so let's start with Snort 2. We'll take a look, and so again, make sure we're all on the same page, and move on to Snort 3. Okay, Snort 2, developed by Marty Resch, who was the founder of SourceFire, primarily used as an IDS, IPS, so intrusion detection or intrusion prevention system. And that really depends on how it's deployed, whether it's passive or inline, really. Snort began its life as a packet sniffer. So that's really its history, its lineage is to sniff packets off the wire. It is packet-based, but we have built in over the years what we call provisional statefulness. So it does understand some aspects of statefulness, although it is still a packet-based detector. There are 4 primary components in Snort 2. So this is this diagram is pretty much straight out of the user manual. So the sniffer is what pulls the packets off the wire, and we call that the decoder as well. So that pulls the packets off the wire. It decodes those, and we'd say decode something similar you'd see in TCP dump, right? So it breaks out the fields in the IP and the TCP headers into buffers, and then passes that on to the preprocessor. So preprocessors are kind of the magical part of Snort, at least the first one, and these are very important. They normalize that traffic. They split out the buffers so that and make it available for the rules. So next part is the detection engine, which is where the Snort rules live. So this is where the rules that are written by Talos, or that you write, or that anyone writes, process that traffic and look for those threats, look for those exploits within the packet data. Once a packet matches a rule, then we need to do something about that. So there's an output alerting module from there, and that generates the alert based on the rule that triggered. Okay, a little bit deeper look at those. The packet sniffer, again, back to the sniffer, it uses what's called a data acquisition module, or DAC. I mentioned that because we're going to talk about that a little more in Snort 3. There are several different DACs available for Snort 2, depending on where you're getting a traffic from, whether that's PCAP or different packet architectures. So you can pull packets off the wire in different types of CPUs or different, like I said, processor architectures. Then the decoder is part of that as well. And again, that's similar to TCP dump. Those parses those packet fields so they can be passed on to the other elements. The next step would be the preprocessors. Again, their job is really to present packet data to the detection engine. They can do some alerting, but their alerting is really on anomalous behavior, and it's not really part of that kind of threat detection, deep packet inspection. Normalization is their biggest deal. So when we say normalize, a good example of that is what the HTTP inspect preprocessor does. And that is, most of us are familiar with URIs and HTTP URIs and how they can be encoded, right? So instead of just looking at ASCII, the percent characters and all these kind of special characters in a URI, so that's encoding. So one of the things that the HTTP inspect preprocessor does is it takes all those encodings, and there's probably 12 or 14 different types of encoding that you can do in an HTTP URI, and it reverts that back to the ASCII equivalent. So the rule writer doesn't have to anticipate all the different ways a particular URI that he's looking for could be encoded. He just has to use the ASCII URI, and the HTTP preprocessor will revert whatever encoding is present back to that. So again, helps prevent those evasions. Other examples, fragment reassembly. So that's really the IP layer, fragmentation reassembly, reassembling packets into datagrams. TCP state, again, TCP stream reassembly, again, we're moving into the packet down the layers. And then application aware. So these are the kind of the important ones, again, that usually do most of the heavy lifting. HTTP, you're talking important protocols like SMB, RPC, lots of traffic there. So those are very important. And they are dynamic. You can actually load new preprocessors on startup. Now, preprocessors, again, still on this subject, they have to be sequenced, and they're sequenced really kind of the way packets are architected. So I mentioned this because we're going to talk about how this is different or better in Snort 3. So if we look at from left to right, you have IP defragmentation there. So that's the IP layer, so we're going to defragment those and generate events, again, on anomalous conditions if needed. Then we'll move on to the TCP layer, look for statefulness, so we'll be able to understand which packets are part of a stateful connection, reassemble any fragmented TCP streams, because fragmentation can happen there as well. Then we will look at the application layers, and again, this is the important normalization that goes on before it's passed on to the rules engine, which is on the right. So that's not technically a preprocessor, but it's in this diagram just to make it more clear what's going on here. Over the years, again, we've added more capabilities to Snort 3. So instead of those basic 4 we saw before, we split those out, and there's actually split out a couple preprocessors here as well, the specific ones, Frag 3 and Stream 5, kind of just to show the sequence of things that have to happen. So things happen in a sequence in Snort 2, and it's because, again, the way the packet's pulled apart and decoded. And so the sequence is important, and we'll see later, again, how that changes in Snort 3. But as you can see, we go through a number of preprocessors and steps with the rule trees there at the bottom, things that look like little tridents or forks. But basically, that's just showing how that rules are actually grouped according to the ports or services. So when packets are evaluated through the rule set, a packet only has to go through the ports and or services that are applicable to that packet. So we don't have to run a packet through every rule in this case. And finally, or not finally, but almost finally, part of the steps here, the detection engine, this is where the rules handle the packets. So they're going to take that data that was normalized, those buffers that were filled with data from the packets, going to use those based on the rule keywords to search through the packets and look for that those threats. In the output module, pretty straightforward. It's going to generate output. We can do that in standard out, text, or binary. Unified 2 is what we usually use for Snort 2, and that's kind of a modified PCAP format. Okay, so that's Snort 2. So let's take a look at Snort 3 architecture then. What were the goals again? So the goals, more flexible packet processing framework. So we saw how Snort 2 is very procedural, left to right, whatever you want to say, up or down, but it has to go from one step to the next. We wanted to make that a little more flexible. And what would help here is an event-driven approach. So instead of, again, doing it proceduralized, let's do an event-driven approach, which is more efficient. We want to minimize those expensive normalizations. So I have JIT versus JIC. So just in time versus just in case. Snort 2 is a just in case philosophy, right? So again, using HTTP inspect just because it's so popular, we all and most of us understand kind of a little bit about HTTP. HTTP would take the HTTP stream and pull the parts apart, like the HTTP header, the body, various parts of the HTTP packet, and it would make those available to any preprocessors or any rule engines, rule keywords that need those. And that's just in case. So it's going to pull all that stuff out, normalize it, just in case a rule needs it. Just in time would be, hey, let's not pull the stuff out and normalize it until there's a rule or some other preprocessor that needs that data. Then it will do it. That's just in time. So that's more efficient. So we don't have to actually normalize anything unless something else needs it. We still wanted to retain a similar packet processing functionality from Snort 2 because there's nothing wrong with that. It works. So, and it's understandable, and people understand how that works. So we still want to process packets in a similar manner, just better. Multi-threaded, of course, is huge. Save that one for last because it's kind of the first thing people say is that, hey, we heard Snort 2 single-threaded. We want multi-threaded. Well, that's what we have. Snort 3 is a multi-threaded application. It has one control thread and multiple packet processing threads. So the challenge. So what are we talking about, all these multi-threads, and what's really the challenge when it comes to deep packet inspection? Well, one of the big challenges is that network speeds and packet rates are constantly increasing, right? So who remembers when 100 megabits was a fast network, right? But now even a gigabit, my network at home is all gigabit now, right? So in most organizations, it's that or faster. So packet rates have gone up orders of magnitude, whereas CPU processing is not. CPUs have been incrementally getting better, but not that fast. So they have not kept pace with the rate that traffic on the network has been going up. So how do we fix that? How do we address that with Snort 2? So with Snort 2, what we do is we just load multiple Snorts. So in this case, we have a 4 CPU box. So what we've done is we loaded Snort 4 times. There's 4 instances of Snort running, 4 single-threaded Snort instances. And so those are in the red boxes. In the yellow box there, we have a connection hashing application or algorithm that's not actually part of Snort, but it's required if you want to do this. And what it'll do is it'll take connections, and this is where the connection comes in, and it will hash those In the case of the firepower system, now called the Secure Firewall from Cisco, it does a 6-tuple hash based on source and destination IP, source destination port, protocol, and VLAN. So when it hashes those, packets that have the same hash are going to be in the same connection. Those are going to go to the same CPU. And so other connections will be load balanced to other CPUs, and that's how we increase the throughput of the single threaded Snort process to try and keep pace with the speeds that are increasing on the network. So when we do this, though, remember each one being single threaded is kind of an island to itself. It doesn't know about the other Snort processes running. So each one has its own DAC, its own configuration, its own preprocessors, its own rule tree. So those same configurations get loaded over and over again. So for every Snort CPU, you're going to load the same configuration, the same preprocessors, rule trees, etc. So the advantages to this design, linear scalability, right? So you have one CPU, you add another one, you've doubled the throughput of Snort. You add another one, you've added a third again, add another one, 25% again. So every time you add more, you add the same amount of processing again. The downside is duplicated memory structures, right? So that's really the biggest downside here, is that you're just using the same memory to really store the same data over and over again, and it has to do that because the threads can't really share another thread's memory. If we take a look at what this looks like, I've got an example here of one of our systems. It's a virtual machine, actually, that has 3 CPUs that are capable of running Snort in this one, the way the CPUs are divided up in this particular box. So if I run a PS-EF on the device here that's doing this detection, you can see that there are 3 Snort processes running, right? So you can see the command lines there to Snort, and they're all running the same thing. If you look very closely there, you may see that there's some instance 1, instance 2, instance 3, which I haven't highlighted here, but basically logging to different places, but they're pulling the same configurations and running 3 times the Snorts. In Snort 3, this is what that looks like. So Snort 3 is, again, multi-threaded. So it's threaded to use multiple cores. There's one control thread, and then you can have up to 32 packet threads per control process. One of the things you get from this is a faster reload, right? So if you have a number of Snorts in the previous example of Snort 2, if you have 5 or 10 or 20 different Snort processes, when you reload, you have to reload 20 processes, reload all that stuff 20 times, all your configurations, your rule trees, your network maps, where with this, you're only loading that one time. So you're loading it one time, and then you're spinning up multiple packet processing threads. Example, or one advantage of this is, of course, less memory, right? So using one copy of this, you're only using the memory for 1 times your configuration rather than n times, depending on how many CPUs you have. This gives you more room left over for IPS rules and a larger network map. So this is why Snort 3 uses a lot less memory than Snort 2. Now, if you look on the right, you can kind of see how that works. You've got a control thread on the left part of that diagram and the packet threads on the right. Now, there's still an external load balancing process. The dotted line is the Snort binary there. Outside of that, there's some load balancing process that's got a load balance across those packet threads. And, of course, the Firepower system does that. And also, there is a open source DAC, data acquisition module, available to do that as well. This is what it looks like, that same device. So I took that same device I showed previously in the screenshot, and I loaded Snort 3 instead. That was Snort 2 previously. This is Snort 3. And as you can see, I just ran that PS-EF, grep Snort again. Now there's only one Snort process. So instead of 3, there's only 1. Now, you notice there's a parameter there, Z3. And that is what is telling Snort to spin up 3 packet processing threads. So you can use the Z or the --max packet threads parameter there. Now, keep in mind, this load balancing still load balances the flow across a single packet thread. So there may be one control thread, multiple packet threads, but those multiple packet threads flows are still load balanced across those the same way they were in Snort 2. So a single flow is still going to go to a single packet thread. We understand there's elephant flows issues with keeping that each flow on its own CPU, but at this time, this iteration of Snort 3, that's how this works. Look for some changes later down the road. We don't know how long, but that is definitely something that is on the top of the list as far as addressing and how we're going to address faster processing of those elephant flows by leveraging multiple CPUs for a flow. Snort 3, plugins and inspectors. So inspectors are the new word for preprocessors. So just do a search and replace in your brain when you're talking about Snort 2 to Snort 3 and change preprocessor to inspector. Each inspector, in fact, everything is pretty much a plugin with Snort 3. So the rule keywords are all plugins. There are a number of different types of plugins here if you're interested. So we have codec, inspector plugins, IPS option plugins for rules, custom actions, loggers, MPSE, which is a multi-pattern search engine, shared objects. So lots of different types of plugins, and again, over 200 plugins in Snort 3 currently, and which makes it easier to program, easier to add plugins because they're much more atomic and smaller to program. Okay, let's compare the Snort 2 to 3 processing again. So we've seen this already, how Snort 2 processes. So again, one of the issues that can happen here is a preprocessor such as the HTTP could extract and normalize data that's actually not used later on. So it just doesn't know. That's why we call it just in case. So in Snort 2, we could sit there and pull apart some fields in the HTTP packet, for instance, normalize those, make them available, and maybe no rule ever needs one of those or a couple of those fields. If no rule ever needs it, then we just wasted our time normalizing that. With Snort 3, it's still different. So things aren't as linear as they are in Snort 2. There's still somewhat, but there's a lot more functionality there for what we call a publish and subscribe model. So the various plugins will publish what they can make available and then subscribe to what they need. So a rule keyword might say, hey, I need to see the HTTP header, I need to see these parts of the header. And the HTTP preprocessor can publish and say, I have these I can make available. So when the requester subscriber needs a particular thing, the provider, the publisher, will provide it, but it only provides it at the time he needs it. So that's called just in case processing, or just in case buffers. So the buffers aren't populated, they're populated when you need them. Just in time, I said just in case. Just in time processing, so it's just in time instead of just in case. So subscribers can access the raw or normalized data as needed. Okay, so that's a little bit about the functions and the internals of Snort. Let's take a look at how that plays out in the world for you. So first of all, let me mention that Snort 3 consists of kind of three types of code. There's brand new code that was just totally written new for Snort 3. There's some code that was rewritten from Snort 2, taken and rewritten in Snort 3. Some code was ported from Snort 2 to Snort 3. HTTP inspect is an example of something that's completely rewritten. They did not take the HTTP inspect preprocess out of Snort 2 and reprogram it. They rewrote the whole thing for Snort 3. It adds in HTTP 2 support, which is pretty important. A new protocol or newer protocol is HTTP. A lot of people are using it, a lot of sites and servers. So it is fully stateful. So this is less of a packet-based and more of a protocol data unit or PDU-based, flow-based detector. Again, just-in-time buffers instead of just-in-case. New rule options. So, for instance, let's talk about HTTP because that's kind of the most common one. And previously in Snort 2, in HTTP, you could look for a content check and say, hey, look in the HTTP header, for instance. With Snort 3, you can say, look in the HTTP header, but also look inside the user agent string for the browser, maybe. So you can look, there are more buffers there to look deeper, not necessarily deeper, but more accurately into the packet, right? So narrow in your focus into your keywords. You don't have to be searching for data that you don't need. Make it easier on the rule writer and more efficient. Again, flow-based for better evasion resistance. We're talking more about flows here, not about packets. Just some anecdotal information here about HTTP Evader, which is a tool that can be used to try to evade detection. We use it to test Snort to see how well it does that. But the important thing here is Snort 3.0 out of the box, without any changes, was 99% effective against that HTTP Evader, the obfuscations that it throws out. And in fact, that 1%, which is only a handful of around 10 or so evasions, we're already addressing those, probably addressed a number of those already, and those, most if not all of those, will be addressed in short order. So much better at finding those evasions, again, based on the fact that it's flow-based rather than packet-based. A little more in HTTP 2. So previously in Snort 2, HTTP 2 sessions were downgraded to HTTP 1 to inspect them. Now keep in mind that if you do use HTTP 2 or want to inspect it, that's important to you. You probably have to decrypt that. You can't. HTTP 2 is, while it's technically supported without encryption, pretty much all the modern browsers won't support it unless it's an HTTPS connection. So you will have to have that decryption ability to look inside an HTTP 2 packet. It is supported in IPS, App ID, Firewall, and file type detection. They'll trigger for 1.1 as well as HTTP 2 traffic, and will monitor anomalies, protocol anomalies in HTTP 2, just like we did for regular, HTTP 1. Another major change in Snort 3 is the configuration. So the Snort 3 configuration uses Lua instead of, whatever the other one used. So Snort 2, if you looked at the big Snort configuration file, it can be a little bit confusing unless you know exactly what goes where, how to put it in there. There's no real standards, right? It's kind of, I won't say it's random, but it's not standardized throughout the file. Lua is very consistent. The syntax is consistent. This configuration is actually a script that's executed on load. It's not just a static configuration file. So a little example on the right there, you can see we've got this variable here called log limit that's populated within the snortconf file here. And it grabs an environment variable from the OS called log limit, and then uses that later to configure the max queued events parameter in the search engine, so 4 times the log limit. So this is dynamically grabbing that data when Snort loads and configuring a parameter in Snort based on something dynamic in the environment. It also outputs all the semantic errors before quitting, whereas Snort 2 would just output one error and then quit, and then if you change that and fix that error, start it up, and output another error and then quit. This will output all the errors, get a chance to look at all of those before you try to restart Snort again. Now the Snort 3 configuration is not backwards compatible. It can't read a Snort 2 configuration file, but we have an answer for that. So there's a conversion tool called Snort to Lua. Now, Snort to Lua is a binary that will be generated if you compile Snort. So if you download the source code and you compile the Snort binary, one of the other binaries will pop out as part of that make or compile process is the Snort to Lua binary. That will convert your Snort 2 configuration file to a Snort 3 config. It'll also convert your Snort 2 rules to Snort 3 rules. And this is an area I expect to see people using it a lot more, is the actual rule conversion. Because even if you have the Firepower and Secure Firewall product, you probably still want to convert your Snort 2 rules to Snort 3, and you can use Snort to Lua for that. Secure Firewall 7 has a Snort 3 intrusion policy. You can actually import those custom Snort 3 rules. And if you need to do any of that rule conversion yourself, that Snort to Lua binary is available out on the Firepower Management Center under that path for RSFBin Snort to Lua. Another change, Snort 3 Release Manager. Now you can still get the Snort 3 rules in a tarball, but you can also get them through this new light speed format, new package. Contains the rules and the configuration in a Lua format. It is smaller, it's better. If you look at our, again, Secure Firewall, we've traditionally had what's called an SRU, a security rule update, and the LSP, a lightweight security package, which is based on Lightspeed, replaces that. Again, advantages, it's about a third the size, the package of the SRU. More flexibility in what we can do in it, and lighter weight. Snort 3 rules. So in this presentation, I'm not going to go into rules. That'll be a future presentation, but that was a major change in Snort 3 again. So Snort 2 rules, de facto industry standard for intrusion rule writing, but Snort 3 rules are better. They're easier to read, to write, and to verify. If you understand Snort 2 rules, you have no problem understanding Snort 3 rules. Actually, they're more consistent. So the punctuation, comments within the rules, again, some additional keywords. Networks and ports are optional in the rule header, so very interesting. If you've ever written rules, you always had to put a network and a port in there. You don't have to in Snort 3, and we'll see how that works later on. Again, not in this presentation, but in a future presentation we'll dive into Snort rules. More sticky buffers. So Snort 2 had some sticky buffers, Snort 3 has more, and those are keywords that help you again reduce the number of words in a rule and make it simpler to read a rule. New buffers and other rule options. I mentioned those a little bit about HTTP already. The Snort to Lua adoption or conversion Remember, you can use that to ease your adoption. And again, we'll talk about more coming up. There's a quick kind of a left to right comparison of Snort 2 to Snort 3. You can see just some of the major changes or major kind of philosophical differences, I suppose, if you will. Again, preprocessors to inspectors, single to multi-threaded. Snort 2 is, even though it has dynamic plugins, it's still more of a monolithic application, where Snort 3 is really all plugin based. Again, making it easier to write a plugin. You have to know everything except for just how your plugin works. Procedural versus procedural and event driven, just in case versus just in time. Again, down the list there. Ports versus services, packets versus PDUs. I won't call your attention to Hyperscan on the right, about 2/3 of the way down. This is a new technology, a new library that's in use in Snort 3. Again, on an Intel processor. Hyperscan is something that leverages capabilities of the Intel processor to greatly speed up things like PCRE. So the multi-pattern search engines, including the regular expression searches, are several times faster in using Hyperscan. So to summarize, I would say we have a multi-threaded architecture. Again, port-independent protocol inspection, pretty important. We want to be able to find attacks on certain protocols or certain applications, regardless of the port. That acceleration with Hyperscan is a big deal. Again, modularity, easier for Talos or anyone to contribute plugins. That memory allocation, reduced memory is great. Again, better rules, new and improved HTTP inspector. There'll be other new, actually rewritten inspectors as well. Some of those were ported or rewritten, will be rewritten even further. And of course, the lightweight content updates from Talos LSP or Lightspeed. For more information, you can go to the links here. You can go to GitHub and just find the Snort 3 source, talosintelligence.com, of course, and snort.org. I might mention that talosintelligence.com, even though it's a Cisco site, the blog there from Talos does address threats that everyone should be interested in, and we have some Snort information from time to time there as well. So with that, thank you for watching. Appreciate your time, and I hope this helps fill in some of the blanks about Snort 3 and helps you move in that direction. And I almost forgot to say happy snorting.